Something else that could impact performance is using Proxy ARP. Proxy ARP happens when our router is responding to ARP requests on one subnet for a destination on another subnet. This could generate an excessive number of ARPs that could increase ARP traffic, hurting performance. And also, there's a known security vulnerability associated with Proxy ARP. We generally want to avoid Proxy ARP. Let's see now how we can see if Proxy ARP is indeed enabled on an interface and how we can turn it off. Let's go out to the live interface to demonstrate this. Let's go over to router. Let's go over to R4. Okay, we're already on R4. Fantastic. Let's do this. Let's do a show IP interface, fast Ethernet 0/0, to see is Proxy ARP enabled. Yes, it is. Proxy ARP is enabled, and we want to get rid of that. We want to turn that off. So let's do this. Let's go into global configuration mode and then into interface configuration mode for fast Ethernet 0/0. And here's how we turn off Proxy ARP. We say no IP proxy-ARP. Now if we reissue that command, let's do another show IP interface fast Ethernet 0/0, and this time we see that Proxy ARP is disabled. Excellent, that's what we wanted. Because in general, Proxy ARP is not something that's desirable. Again, it can hurt performance and it can result in a security risk. What else might impact performance? Well, we might notice, and again, we're noticing the impact on performance based on the ping round-trip response time. We might have poor performance because we're selecting a suboptimal route. Well, hold on. If we're going in and configuring a static route, aren't we in control of which route gets chosen? Well, a default static route, or not even a default static route, but just a statically configured route, has a default administrative distance of a 1, and a lower administrative distance is more believable than a higher administrative distance. For example, EIGRP is going to have an administrative distance of a 90. OSPF is going to have an administrative distance of 110. But when we configure that static route, it's possible that we're specifying an administrative distance that is higher than the default administrative distance. Let's go to the live interface and let's demonstrate how this might happen. I want to go over to router R2 in this case. Let's navigate over to router R2, and let's do a show IP route, and let's see if we've learned any routes via a dynamic routing protocol. And we have. Look at this. We've got a route to 3.3.3.3. And notice this 110, that 110 is the OSPF administrative distance. Let's add a static route to get here. Instead of learning it dynamically, let's statically configure a route to get to 3.3.3.3. And just want to make sure, I think that is with that's using a 32-bit subnet mask. Yes, it is. Let's go into global configuration mode and let's create a static route. To get to 3.3.3.3, we'll say IP route 3.3.3.3. It's a 32-bit subnet mask. So we'll say that the subnet mask is 255.255.255.255. And I'm going to say my next hop IP address is, let's say 10.1.2.10. Now, here's what might happen. When I'm configuring this, I might configure this with a non-default administrative distance. Let's say that I want to give this an administrative distance of 150. Check out the command. That is a valid static route command. However, if we go back and re-examine our IP routing table, we're going to notice that that newly configured static route, it's nowhere to be found. Why? Because it had an administrative distance of 150, and there's a more believable path to 3.3.3.3. The OSPF learned route has an administrative distance of 110, and that is more believable than 150. And as a result, our statically configured route does not even make it into the routing table. So that's another reason that we might have poor performance, and that is we're selecting a suboptimal route.